Good day guys! I'm Dan Sandil and I'm an industrial designer. So, I've been 3D printing since 2015 and it helps me a lot in making things from concepts to 3D model and then the real thing. Also in prototyping and fabrication. So, come and join us and I will discuss my experience and knowledge about 3D printing and the future of creating things. So, let's get started! The next slide is the types of 3D printer. So this, as you've seen earlier, the SLA or stereo lithography 3D printer was patented by Charles Hall, the co-founder of 3D Systems in 1986. The process of printing involves a uniquely designed 3D printing machine called a stereolithography apparatus or SLA, which converts liquid plastic into solid objects. As you can see in the picture, this is the laser. Then it will this scanner system will project the laser to the object or to the vat where the resins or liquid polymer is in. When the laser with UV light have contact with the resin, it will cure the resin for a few seconds or milliseconds. So next is the digital light processing or DLP. So another 3D printing process very similar to stereolithography or SLA. So the DLP technology was created in 1987 by Larry Hornbeck of Texas Instruments and became very popular in projectors production. It uses digital micromirrors laid out on a semiconductor chip. So the technology is applicable for mobile phones or cell phones, movie projectors, and 3D printing. So for 3D printing, DLP as well as SLA, they both use photopolymers or resins. But what makes SLA and DLP processes unlike is a different source of light. As you can see in this image, the DLP can be printed on a can print the whole layer, while the SLA needs to use selective exposure of light by the laser on each form or side. Like in this one, this use only one layer. You can cure the whole layer. So as you can see in this picture or video, like this one. So after it tilted, it will cure another layer after a few seconds of curing using a UV light. This is a DLP 3D printer. So another sample of SLA is a Formlab 3D printer. So next is the most common 3D printer and the most affordable printer in the market today. So it is a fused deposition modeling FDM, or what they call fused fabrication filament, because they use filament, of course. Was developed and implemented at first time by Scott Crump, Stratasys Limited, founder in 1980s. So a well-known sample of a printer company is MakerBot or Multimaker, which is nearly identical technology known as fused filament fabrication or FFF. So FDM is I think they Stratasys trademarked the FDM. So you need to they call it FFF or fused filament fabrication. So next is the selective laser sintering. Like this one. So a technique that uses laser as power source to form solid 3D objects. So this technique was developed by Carl Deckard a student of Texas University, and his professor Joe Beeman in 1980s. So as you can see, almost the same with the SLA, but this used powder. This used a powder plastic. Then the laser beams to the plastic to make a form. Okay. So next is selective laser melting. So this type of printer can print a metal or metallic parts or item. So it is a technique that also uses 3D CAD data as a source and forms 3D object by means of a high power laser beam that fuses and melts metallic powder together. The history of SLM started with German research project held by group of Fraunhofer Institute or ILT in 1995. So as you can see, same with the technology of SLA, but the system is they will put there's a roller that will push the powder to the vat or bed, then the laser or scanner system will cure the powder metal. So next is the electronic beam melting or EBM. So EBM is another type of additive manufacturing for metal parts. It was originally coined by Arkham AB Incorporated in the beginning of this century. The same as SLM, this 3D printing method is a powder bed fusion. So while SLM uses high power laser beam as its power source, EBM uses an electronic or electron beam instead, which is the main difference between these two methods. The rest of the process is pretty similar. Another type of 3D printing technology is laminated object manufacturing or LOM. So this is developed by the California-based company Helicis Incorporated. During the LOM process, layers of adhesive coated paper, plastic or metal laminates are fused together using heat and pressured and then cut to shape with a computer-controlled laser or knife. So it's like a tape, then overlap it together and then cut by the laser beam or a knife or like a CNC. So post-processing of 3D printed parts includes such steps as machining and drilling, as I've mentioned a while ago. So next technology is the 3D bioprinting. So 3D bioprinting is the utilization of 3D printing like techniques to combine cells, growth factors, and biomaterials to fabricate biomedical parts that maximally imitate natural tissue characteristics. So as you can see in the image below, so this is a bio ink and a 3D printer nozzle. So this is the bioreactor. Okay, utilizes the layer by layer method to deposit materials known as bioinks to create tissue-like structures that are later used in medical and tissue engineering fields. So covers a broad range of biomaterials used to print tissues and organs to help research drugs and pills. So emerging innovations span from bioprinting of cells or extracellular matrix deposited into a 3D gel layer by layer to produce the desired tissue or organ. In addition, 3D bioprinting has begun to incorporate the printing of scaffold. So this scaffold can be used to regenerate joints and ligaments, like on the image on my back. So the next is the powder bed and inkjet head 3D printing. So the binder jet 3D printing known variously as the powder bed and inkjet. So, it's like a SLS, a powder using a powder, and then the inkjet or color is like the resin that can be cured. So that's basically the technology. So, is a rapid prototyping and additive manufacturing technology for making objects described by digital data such as a CAD file. An inkjet print head moves across a bed of powder, selectively depositing a liquid binding material. A thin layer of powder is spread across the complete section and the process is repeated, which each layer adheres to the last.